Hi, this is Alex from devstories.eu, Alembic Database Migrations, Episode 8 of 8. For modern containerized applications, relying on manual command line scripts to prepare your database before your app starts is an operational headache. Your application should be smart enough to verify and update its own schema on startup. To do that safely, you need production power-ups. Most developers only know Alembic as a terminal tool. You type an upgrade command and it modifies the database, but the command line interface is just a thin wrapper. Underneath is Alembic's programmatic API. You can trigger migrations directly from your Python application code. This allows modern backend frameworks to execute schema updates automatically during their startup routine, ensuring the code and the database are always perfectly synchronized. However, doing this naively introduces a subtle problem. When you run a migration programmatically, Alembic defaults to its standard behavior. It reads your configuration file, creates a brand new database engine, opens a connection, runs the migration, and closes it. But your application just started up. It already created an engine and initialized a connection pool. Letting Alembic spin up an entirely separate connection during startup is inefficient. More importantly, it can be dangerous. If your application's startup sequence holds a lock on a table, Alembic's separate connection will hang waiting for that lock, causing a deadlock that crashes your container. This is also a major issue if you run automated tests against an in-memory database. In that scenario, a brand new connection points to a completely empty database, meaning your migrations will fail to apply to the data you're actually testing. You solve this by handing your application's active database connection directly to Alembic. This is done using the Alembic configuration object. First, your application code instantiates a configuration object, pointing it to your main initialization file. Here is the key insight. The configuration object has an attributes dictionary. This acts as a bridge for passing live Python objects into the migration environment. You acquire an active connection from your application engine, and you assign it to a key called connection inside that attributes dictionary. Next, you call the Alembic programmatic API, specifically the upgrade command, passing it your modified configuration object and telling it to upgrade to the head revision. But Alembic does not automatically know what to do with that injected connection. You must modify your migration environment file to complete the circuit. In the section of your environment file that handles online migrations, you add a simple check before the setup happens. You instruct the script to look inside the configuration attributes. If it finds a connection there, it skips creating a new engine. Instead, it configures the migration context to use the connection you provided. If it does not find a connection in the attributes, it safely falls back to normal behavior, creating a new engine from the database URL. This fallback ensures your command line tools still work exactly as they did before when you run them locally. By designing your system this way, you transform migrations from an external deployment chore into a native, predictable part of the application lifecycle. When a new instance spins up, it requests a connection, handles its own upgrades within that session, and seamlessly transitions to serving traffic. That wraps up our series on database migrations. I highly encourage you to explore the official Alembic documentation and try these programmatic configurations hands-on. If you have ideas for entirely new topics you would like to hear, visit devstories.eu and let us know. That is all for this one. Thanks for listening and keep building.